Hi, welcome back to the channel. So we're going to look at infinite series, and what we're going to focus on is how to come up or how to determine the radius of convergence as well as interval of convergence of a given series. Okay, so I would have chosen to make separate videos for these two parts, which is the radius of convergence as well as the interval of convergence. But um, in a long term, uh, the interval of convergence depends on the radius. Okay, you can't find the interval of convergence of a given series without having to find the radius, but you can find the radius without having to find the interval of convergence. So what we can say is the interval of convergence depends on the radius, but the radius doesn't depend on the interval of convergence. So I'm going to use two examples, and in those two examples, I'm going to explain everything that you need, all the steps that I feel you need to simplify your work when it comes to such. I'm going to highlight it for you. So make sure to say you watch till the end so that you don't miss out anything that might be very useful to you. Okay, so when it comes to finding the radius, one thing that you have to keep in mind is that we are going to be applying one of the tests that we earlier talked about, which is the ratio test. You can check out the link in the description below, where I talked about the ratio test and what it's all about. Yeah. Okay. So that is our ratio ratio test, and it was we can summarize it by writing to say you have the limit. If you have given your series, okay, a sub n, you're going to say the limit as n approaches infinity, then you're going to have your a sub n plus 1 divided by a sub n. Okay, so the thing is that if what we get here, we write it like this, we say it's less than what, less than 1, we can talk about the series converging. Okay, we can talk about the series converging. So one thing that is going to be, that is actually clear right now is that if we were to say it's greater than 1, we would have talked about it uh, being divergent. Okay, but I'll not really talk about divergent here because I'm just talking about convergence. All right, so what I have right here, this is just more like your R. Okay, that's more like your R. So why am I talking about the ratio test? The ratio test just helps you to find the radius. Okay, it just helps you to find the radius. So the way you can basically write it is this way. From what I have here, it's more like having x minus c, where c is some constant, where you say it's less than what, less than r. So this r right here is the radius. Okay, so we're going to use this method to come up with this format. Then whatever that you're going to have here is going to be what, is going to be a radius. So even if you have something like, let's say you have x minus c over, let me say b, then you have less than r, like that. This is not complete. You can't just say your radius is, okay, let me not put r, let me put y, like that. Okay, so the way it is that for me to indicate the actual value of r, like the final value of r, I'm going to have to write it in this form. Okay, so meaning this is going to be like x minus c, then you just have to multiply both sides, and you don't really have to worry about whether or not that is positive or negative because of these absolute value symbols that you have there. Okay, so meaning this is going to be less than by. So having written it in this form, it simply tells me to say my radius is equals to by. This here is our radius. The reason why I'm doing this is that you're going to come across some examples whereby you have a fraction like this. Okay, when you have that fraction, that tells you that you're supposed to do it more like the cross multiplication so that you leave it in that form. Okay, so those are one of the few things that you have to know. More especially this part here is very very important. Okay, so about the interval of convergence. Okay, so this here, when you write it in this way, what you have here is automatically the radius of convergence. Now, what about the interval of convergence? For the interval of convergence, you just have to remove these absolute value symbols. When you remove those absolute value symbols, you can have minus r on this side less than x minus c less than r, like that. Okay, so now we you are supposed to have only x on the middle here. So what does this mean? It means you're supposed to add plus c and plus c on the other side. Okay, so meaning this is going to be something like c minus r less than x, then you have like c plus r. So this one here is what is termed as the interval of convergence. So from this radius of convergence, we just had to remove the absolute value symbols. You have your minus r on the other side, which is this one, and the positive r. So you're just supposed to have an x here. Okay, so now the c goes on this side and goes on the other side. All right, so here now this is not final. There are situations whereby, let me say, uh, this part here, let me write it this way. Let me say this part, for simplicity purposes, something like this. So let me say this is a and this is b. Okay, so there are times whereby, let's say you have a less than x less than b. Okay, this is the first scenario. There's another one, but of course it always comes in this way, but I'm talking about possibilities that might be there as the final answer. And let's say you have a less than or equal to x less than or equal to b. Another one is where you have, let's say it's a less than or equal to x less than b, or you have a less than x less than or equal to b. So you have one, two, three, four. So among these four, one of them is true. It does not mean this is always the case when it comes to the interval of convergence. That's very important. That's where that's where most make a mistake on such questions. It's not always that it's less than. Sometimes it's less than or equal to and the like. So what do you do for you to know which one of these that you are going to use? When you have found the interval of convergence, the endpoints, what are those endpoints? Is this one here, c plus r and c minus r, which I've summarized as a as well as what? As well as b. So those values, you're supposed to test them for convergence. Are they converging or are they diverging when you plug them back in your what? In your a sub n, which is your series. Okay, because you'll be given your series as infinite sum. Let's say n is equals to 1 to infinity, then you're going to have what? Your a sub n. So when you plug in the a sub n where you have x, okay, where you have x, plug in with a, determine if it converges or it diverges. Plug in with b, determine if it converges or diverges. Then from that you'll be able to tell whether a is included or is not included, whether b is included or not included. That's what I mean. Okay, so now let's go ahead and look at our first example. Or maybe before I do that, there's actually something else that simplifies everything. There's something that simplifies everything. So for the interval, remember the interval which I indicate as I, we can just write it more like to be c. We said c minus r less than x less than c plus c plus r. But remember to test the endpoints. These are your endpoints. Then there are times whereby your work is simplified. So this is just more like the summary of everything that I've just talked about here. Okay, let me just write that as the summary. So one, on the summary, the first one is this. Okay, the first one is that if you have the limit, let's say you have the limit as n approaches positive infinity, then you are evaluating, of course, using the the root test. You have your a sub n plus 1 divided by a sub n. If this is equals to 0, if after doing this you get a 0, excuse me, this tells you to say your r is equals to infinity. Then your interval of convergence is equals to, it starts from minus infinity to positive infinity, meaning the series converges for all values of x. Okay, for all values of x. Pardon me, that's I. Uh, it's I, meaning interval. Okay, so what about the second one? The second one is if you evaluate, you say limit as n approaches infinity, you have your a sub n plus 1 divided by a sub n. If this is equals to infinity, this tells you to say your r is equals to 0. Then the interval is not really more like an interval, it's just at one point. Okay, it's just at 0. So this that you have right here is going to simplify your work a lot, because there are some cases whereby you end up with 0, or you end up with what? You end up with infinity. So if you end up with 0 after evaluating, just write to say the radius is infinity. The interval of convergence, it just need to say the series converges for all values of x. Then where this is infinity, mean know that your r is equals to 0. Then for the interval, not really an interval, but it's just like it's at one point, so that's just going to be a 0. Okay, so that's basically how we do that one. Okay, so this was all about the intro and things that you need to know about the radius as well as interval of convergence. So I'm going to end this video right here. In the next video, I'm going to talk about those two examples, and we are going to apply everything that I've talked about here. So thank you very much for watching, and we'll catch you in the next one.